Hello students, in today's session, we will go through another technique of solving the problems using the dynamic programming concept that is called as multi-stage graph. In a multi-stage graph, we will be given with a particular graph. We can call this graph to be a weighted directed graph. As you can see here, each and every vertices are connected through the certain edges, and each edges have a particular weight, and also the edges are directed, right? So we can call it as a directed weighted graph. In this set of graphs, this set of vertices are placed within certain stages. Now here, if you can look at here, I can consider the vertex 1 as the source vertex. I can denote it as S here. The source vertex, I can denote it as a S. And the one more vertex on the other end, I can call it as a T. T is nothing but the sink vertex or destination vertex. I need to find out the path between the source to the sink through various vertices, right? Now, here, if you can notice that each and every vertices are placed in a particular stages. Okay, we can find in this graph as there are 5 different stages. The stages are denoted as the letter V here. V1, V2, V3, V4, and V5. All these are the stages of this particular graph, multi-stage graph. Now, in the stage number 1, in V1, we have only one particular vertex called as 1, which is our source. And if you can look at the other end, the last vertex, that is V5, in general, we can call it as a VK, wherein we will be having only one vertex called as a sink vertex, which is denoted as T. Between these two, in general, if there are K number of stages, then in middle, we will get K minus 2 stages. So in this, the total number of stages are 5, and here we have that is 5 minus 2, that is 3 as the in middle, the stages of this particular graph. Now, in the stage number 2, that is V2, we have this set of vertices, and stage number 3, we have again a set of vertices, and stage number 4, we have another set of vertices. The multi-stage graph is that we need to find out an optimal solution that gives us the minimum path or the minimum cost of a particular path from the source to the destination. I need to find out the certain path that exists in this particular graph, wherein from the source vertex, I need to reach to the destination vertex through the intermediate stages. And in every intermediate stages, we have a set of vertices. If there are k number of stages, then the number of decisions that we will have to make in the multi-stage graph is equals to k minus 2. Right? So we have to exclude the source and the destination. Excluding those things, we will get the intermediate stages. So at every intermediate stages, we will have to make the certain decisions. What actually decisions means here? For an example here, if you look at now from source, that is vertex 1, I can reach 2, that is the last vertex 12, using or through the any other vertices in the stages. Suppose if I'm sticking to one particular stage, for example, if I'm sticking at the stage number 2, and in the stage number 2, there might exist multiple vertices. So I need to find out how much will be the cost if I travel through each and every vertices by applying certain formulas, and using those particular formula, we will come to know that the minimum cost that is required if I travel from any one of the vertex. Then the minimum I need to select. For an example, students, here from vertex 1, I can reach vertex 2. Then if you look at here from vertex 2, if I want to reach the destination 12, then from 2 to the next stage, there may exist 3 different paths. One that is from vertex 2 to the vertex 6. There may exist another path, vertex 2 to the vertex 7, and there exists another path that is from vertex 2 to vertex 8. Then there are three different paths. I need to calculate the how much it will cost if I go with these particular directions. So at every stage, I need to make the decisions. So that will give us the minimum cost. And every decision we have to select the minimum cost so that we can reach the destination with the minimum values or the minimum cost for every edges. Let us try to go through the what formulas are and how we can calculate the solution for the multi-stage graph. The solution to the multi-stage graph can be calculated in two different ways. One is in the forward technique and other is in the backward technique. Forward technique wherein if we select one particular vertex and then from that particular vertex, we will try to calculate the cost in a forward direction. That is the vertex which are coming in front of that. And in the backward, we will try to calculate the cost of a particular vertex by finding the previous stages values. First, let us proceed with the forward approach. Now, consider this particular example wherein we want to calculate the solution, that is the path from the source, that is S here, vertex number 1, to the vertex 12, that is our sink or the destination. Now here, the formula is cost of ij is equals to minimum of C of j comma L plus cost of I plus 1 comma L. Now try to understand the meaning of every characters here. Now the cost ij, here, ij means I is the stage number and j is the vertex at that particular stage. For an example, if I write cost of 2, 3, cost of 2, 3, that means if I, in this particular graph, I can denote as this as the stage 1. Let us write the stage numbers here, 2, then this is 3, then this is the stage 4, and then this is the stage 5. So if I want to calculate the cost of 2, 3, 2, 3 means 2 means the stage is 2. In this particular stage, okay, the vertex 3, that is this particular vertex. So cost of this particular vertex, that is 3, in the stage number 2, at the stage number 2, I need to calculate. How can I calculate? By calculating the minimum among, because there might be existing multiple paths. Out of those multiple paths, I need to select the minimum value, right? So minimum of C of JL. So J means the same as Ij here, that is vertex number. So from this particular vertex to the L. L means the next vertex which I'm selecting in the next stage. Okay. In the forward approach, we will try to calculate the cost in the forward direction by calculating the next particular vertex cost. So J comma L here indicates that suppose if I want to calculate through from 3 to 6 onwards, then CJL means this CJL means it is nothing but the vertex L J is 3 and L is going to be 6, which is placed in the next stage. Okay, plus cost of I plus 1 comma L. Again, notice here there is a cost. Cost means the first number here, I plus 1 is the stage. So I was what actually? It was 2. 2 plus 1 is 3. Means in the third stage, L is nothing but here 6. So the cost of this particular 6. So I need to know the cost of 6, and then by adding that cost of 6 to the C of JL, that is this edge, that if I get that, then I will be finding out, or I will be getting the values or the cost of 3 here. As of now, just try to remember that whenever in this particular formula, if we use cost word as a cost, I comma j, I means it is vertex. Sorry, I means it is the stage and j means it is the vertex. Cost of ij is read as cost of vertex j at the stage I. Okay, C of JL means it is the edge cost between that particular vertex J and the L, which will be placed in the next stage. Okay, and we know that if there are k number of stages, then there will exist k minus 2 as the decisions. So here there are 5 stages, 1, 2, 3, 4, and 5 stages. Then we will have to make k minus 2 as the decisions, because the source 1 and the destination stages we need to exclude. Excluding that, we will get only 3 different stages. At every these 3 stages, we need to make the decisions. Okay, now let us proceed further in solving this particular problem. Let's clear all the drawings from here and then start with the calculation of this particular stage. So total number of stages are k is 5 in this case, and the first decision, that is k minus 2, we will try to make. K minus 2 means 5 minus 2, that is 3. 3 means the stage number 3. Stage number 3 means at this particular stage we are trying to calculate, or we are trying to find out the decisions. We are trying to make the decisions at this particular stage right now. So first is that we need to calculate the cost of this particular vertex, right? Cost of this vertex 6 is what actually it is placed in the stage 3, and the vertex number is 6. That's why notice here cost of 3, 6. 3 means the stage, that is third stage. 6 means it is the J value. J means the vertex number. So this vertex number 6. So cost of this means from here, if I want to travel or I want to reach to the destination, then there might exist 2 different paths. One path is in this direction, that is through the vertex 9 in the fourth stage, or there exists one more path, that is from 6 to the vertex 10 and then to the destination. Again, this stage, that is this particular vertex 10, is also placed in the same stage which is next to it. So now I need to find out the minimum cost of these 2 different paths by substituting the values here. Now minimum of, okay, now 6 is what actually C of JL. C of JL means from this vertex to the next vertex in the next stage, the edge cost is 6. So that is CJL, that we get it as a 6 here, plus then the cost of this particular vertex. Cost of this vertex is what? Basically, this vertex is 9 here. That is nothing but the cost of 4, 9. 4 means it is placed in the fourth stage and vertex number is 9. So cost of 4, 9. This is first path, right? If I want to reach to the destination, then in middle I may get this particular vertex. So if I know the cost of this vertex 9 and the edge cost I already know between the vertex 6 and 9, and then if I add those two, then I will be getting the cost of this 6. Okay, now as we know, we have seen that there exists a one more path here. That path is what? From the vertex 10, that is through the vertex 10, right? Now try to find out the cost of that also. So a comma, then 5. 5 is nothing but the edge cost between 6 and 10. This particular edge cost, that is 5, that is C of JL. C of JL is going to be 5 in this case, then plus cost of this vertex. So this vertex is what actually? It is placed in the fourth stage and the vertex number is 10. That is cost of 4, 10. That is what we have written here, cost of 4, 10. Now, if we substitute the values here, let us see what we get. So minimum of 6 taken as it is, then cost of 4, 9. So 4, 9 means fourth stage, ninth vertex. From this particular vertex to the destination, that is T, there does not exist any in-middle paths or the in-middle stages. There is a direct only edge. What is the cost of that? It is 4. So cost of 4, 9 is going to be 4 here, right? In the same way, 5 plus cost of 4, 10. 4, 10 means The stage number 4, the vertex 10. So from 10 to the destination, there is a direct edge. What is its cost? It is 2. So that 2 is substituted over here. This 2 is nothing but cost of 4 comma 10. So here, if we calculate 6 comma 4, 6 plus 4, we get it as a 10, 5 plus 2, we get it as a 7. So minimum between these two is definitely the this particular value 7. So 7 is retained here. So minimum of this one, either from these two, right? One from these two will be taken as the minimum value. So we can write 7 here. So 7 means actually what? It is nothing but the cost of this particular edge. Let me undo certain things here so that we can understand what actually this particular cost is. Okay, now cost of 3,6 we retrieved as 7. How? That is cost of this particular vertex. Third stage, sixth vertex. From here, if I want to reach to the destination, then its cost will be 7. The cost will be 7. Okay, and how I can reach? I can reach from this particular vertex. I can reach from this particular vertex here. Okay, now in the same way, in the third stage itself, I have two more vertices. One is 7 and other is 8. Now, as I said, we are going to discuss on the dynamic programming. Now here, from this particular stage, I can travel to the destination, right? This is one of the solution. Now I need to find out the solution from the other vertices as well. Then I can decide which vertex gives me the minimum value. And the one which gives the minimum value, that particular vertex, I'm going to add it into my solution, right? Now we need to calculate the path from the vertex 7, which is placed in the it is placed in the third vertex. It is clear, all the drawings. Okay, now cost of 3,7. 3,7 means the third stage vertex is 7. From here, again here there exist two different paths. So minimum of the edge. Suppose if I'm taking this particular edge first time, this vertex, then the C comma JL is going to be 4. That is edge cost. Then the cost of this vertex. Cost of this vertex is 4 comma 9. That is 4 plus cost of 4 comma 9 comma. The second path is from 7 to the vertex 10. So the edge cost. So edge cost is 3. So 3 plus cost of 4 comma 10. 4 means from the in the stage 4, the vertex 10. So cost of this particular vertex I need to select. Okay, then the next, if you substitute the values, 4 plus cost of 4 comma 9. So from 4 comma 9 means from here to here the cost is 4. So I can substitute it as a 4. Then the cost of 4 comma 10. 4 comma 10 means stage 4 vertex 10. From here to the destination the cost is 2. So I can substitute this value as 2 here. Now minimum between these two is definitely this one. 4 plus 4 will produce us a 8. So we will not consider this one. Rather, we will consider this particular path, that is 3 plus 2, which will give us a 5 value. So this 5 means what? The cost of 3,7. Cost of 3,7 means from this particular vertex at the stage number 3, vertex 7, I can reach to the destination. And the cost of that particular path will be 5. And that is through the vertex 10. So this is the path. If you notice here, in the previous one, from this vertex, this was the path and the cost was 7. Now here, between these two, I am getting a minimum value or the lesser value in this particular vertex. Now let us try to calculate the third one, that is from the vertex 8, right? That means cost of 3,8. 3,8 means third stage vertex number 8. Again, here there exist two different paths. So first one, minimum of 5. 5 is nothing but edge cost between 8 and 10. 5 plus cost of 10. Cost of 10 is actually what? cost of 4 comma 10. 4 means the stage number 4. Okay, comma 6. 6 is the edge cost between 8 and 11, and then cost of 4 comma 11. 4 comma 11 means this particular vertex. Okay, now if we substitute these values, we get 2 and 5 here. Okay, between these two, the minimum is this one, that is 5 plus 2. 5 plus 2 means if I go through the vertex 10, so this particular path gives me a minimum path from the vertex 8, which will give me a path value as 7. Now, out of these three, at the stage number 3, there are 3 different vertices, 6, 7, and 8, right? Cost of 6 is 7, cost of 7 is 5, and the cost of 8 is 7. So out of these three, minimum is going to be what? The 7th vertex. So this particular vertex will be taken as the minimum cost. So the decision at this stage is that, okay, in the third stage, I'm going to select the vertex 7 because that will give me a minimum cost. And when I select this one, I have to travel through 7 to 10 and then 10 to 12. Okay, now let us proceed with the next set of decisions. This is the first set of decisions that we made at the k minus 2 stage. K minus 2 stage means the third stage. Okay, now we will try to make the decision in the previous stage, that is 2, and then finally from the stage 1. Now at this stage, we know that the cost from this particular vertex to the destination, or whatever the values we have computed so far, these values we need to remember. These values are required in order to calculate the next set of decisions. The next stage we are going to look upon is k minus 3, that is stage number 2. In the stage number 2, what we have 4 different vertices. In the stage number 2, we have 4 different vertices. From each and every vertices in the stage number 4, we need to find out the cost. So now first one, that is cost of 2 comma 2. 2 comma 2 means at the stage 2, the vertex 2, that is this particular vertex. Now here you can see there exist 3 different paths. One, that is from here to second stage, I can go to the next stage, that is third stage, and there are 3 different paths. From 2 to 6 I can go, from 2 to 7 I can go, from 2 to 8 also I can go. There are 3 different paths. I need to find out the minimum among them. So cost of 2 comma 2 is going to be minimum of 4, that is cost edge 4, plus cost of third stage vertex 6, that is cost of 3 comma 6, cost of 3 comma 6, comma, then in the third vertex, third stage, I have another vertex here, that is 7, right? So cost of this will be what? 2. That 2 is nothing but the edge cost between 2 and 7, which is 2, plus cost of this 7, that is 3 comma 7, cost of 3 comma 7, comma, the third path is between here, that is through the vertex 8. So this will be the edge cost, that is 1. So 1 plus cost of 3 comma 8, that is third stage vertex number 8, that is 3 comma 8. Now these values 3 comma 6, cost of 3 comma 6, cost of 3 comma 7, and cost of 3 comma 8 we have calculated in the previous stages. Those values we are going to substitute here. Okay, so it is going to be minimum of 4 comma, this value was 7, so we substitute as a 7, and the cost of 3 comma 7 was 5, so we are substituting 5, and the cost of 3 comma 8 is 7. Okay, now out of these 3 values, the minimum is this one, 2 plus 5, that produces the value as 7. Okay, so from this particular vertex, second stage, second vertex, okay, if I travel throughout the vertex 7, then I may get a minimum value. So the cost of this vertex, that is vertex number 2 in the stage 2 is 7 here. Now in the same way, we need to now calculate the cost of this vertex also. Okay, let us clear the drawings here first. Okay, now the next is that the cost of 2 comma 3. 2 means second stage, vertex 3. So cost of 2 comma 3 is equals to, now here you can see there exist two different paths. Two different paths means we need to find out the minimum out of those two. So first one is we will go in this direction, that is 3 to 6. So the minimum of 2 is nothing but this edge cost plus the cost of this vertex. Cost of this vertex is actually what? 7 that we have calculated earlier. So that is cost of 3 comma 6 comma 7. 7 is the edge cost between 3 and 7 vertices, that is 7 here. 7 plus cost of 3 comma 7, third stage, 7th vertex, right? So cost, these two values we have populated, calculated in the previous step. Substituting those values, we get 7 and 5 respectively, right? So here minimum is going to be this particular value, 2 plus 7, that is 9. That means cost of 2 comma 3, this particular vertex, in order to reach to the destination, is going to be 9. The same way, the remaining two vertices we need to calculate. The next vertex, that is 4 here. Cost of 2 comma 4. Cost of 2 comma 4, that is second stage, fourth vertex. From here, if I want to reach to the destination, then I need to find out here. If you can notice, there exists only one path. So we no need to make any minimum of that one because we have only one particular path. So 11, that is the cost of this edge, plus cost of 3 comma 8. Cost of 3 comma 8 that we have calculated in the previous stage was 7. So 11 plus 7, we get it as 18 here. Okay, that is 18 is cost of 2 comma 4. That is from this particular second stage, vertex 4. From here, if I want to reach to the destination, then it will cost me 18. The last one is the vertex 5 in the stage 2. That is 2 comma 5. So again, here there are two different parts. So minimum of the edge cost, that is 11, plus cost of 3 comma 7 comma, then the edge cost of 5 comma 8, that is 8, plus cost of 3 comma 8. So these two values we are going to calculate. Again, these values have been calculated earlier. So if you substitute, we get a 5 and 7. So minimum between these two is going to be 15 for this set of values. So the cost of 2 comma 5 is 15. That is second stage, fifth vertex. Now again, here if you look at the minimum in this particular stage, right? In this particular stage, stage number 2, okay, stage number 2, we have tried to calculate the cost of each and every vertex to reach the sink or the destination. And these are the values. Now, from the vertex 2, I get a 7. From vertex 6, I get a 9. From vertex 4, I get a value as 18 and 15. Among these one, the minimum is definitely the vertex 2, which produces the cost value as 7. That means I'm going to consider vertex 2 as my one of the vertex in the solution. Okay, now these are the decisions that we made in this particular stage. Now we are left out with one more decision that we need to calculate here. Let's clear the drawings, proceed with the next stage calculations. In the next stage calculation, that is k minus 4, we get k minus 4 as 5 minus 4 as 1, stage 1. So we need to calculate the decisions, or we need to make the decisions over here. From vertex 1, right, I can have different paths here. From vertex 1, I can go to vertex 2 or 3 or 4 or 5. But I need to find out the minimum out of that one. So cost of 1 comma 1. 1 comma 1 means stage 1, vertex 1 is going to be minimum of the cost of this edge 1 to 2, that is 9, plus cost of 2 comma 2. So cost of 2 comma 2 is going to be 7. So 9 plus 7. Again, these values we have populated in the previous decisions. Okay, comma, the next one, that is from vertex 1 to vertex 3, edge cost is 7. 7 plus cost of this particular vertex 3, which we have calculated as 9. So 7 plus 9. Then the next one is cost of the edge 1 to 4, that is 3. 3 plus cost of the vertex 4. Cost of the vertex 4 was 18. So this is 3 plus 18. Okay, then comma, the last one is the edge cost, that is 2, that is 1 to 5, plus the cost of this vertex 5. Cost of vertex 5 was calculated as 50. Now here, out of these two, the minimum one we need to find out. So we get a minimum value here as this one, 16. Again, you can see here there are two different minimum values, 9 plus 7 or 7 plus 9. But here I'm going to choose the first one, that is. Now, what are the stages? What are the, let us try to find out the vertices which we have selected here between the stages. Stage 1, the vertex is 1, means this particular vertex I will choose first because this is my source. Then stage 2, the vertex 2 I will select, means the stage 2, this is the vertex. Then stage 3, the vertex is 7. In the stage 3, the vertex 7 will be considered in my path. Okay, then stage 4, the vertex 10, that is this particular path. And in the stage 5, there exists only one particular vertex, that is nothing but our destination or the sink, right? So if I have the path in this order, then the cost of this particular path will be minimum here, the minimum cost. That is from 1 to 2, 2 to 7, 7 to 10, 10 to 12, and the cost is nothing but 16. The cost is nothing but 16 here. How 16? If you calculate 9 plus 2, that is 11, 11 plus 3, 14, 14 plus 2, 16 will be the cost. This is in the forward approach. In the forward approach, we make our decisions at every stages, obviously, but at every stages, we try to find out the cost of its upcoming or the next vertices in the next stages. In the backward, we just do the same thing with the previous thing. Okay, if let us move to that backward approach here, the formula I will just show you, and using that particular formula, you can try to calculate. Now, the formula here, backward cost of ij is minimum of, again, backward cost of I minus 1 comma l. Now here you can notice I minus 1. I minus 1 means if I select one particular stage, for example, if I am selecting one particular vertex in one particular stage, if this is the vertex and the stage, then it's previously the vertices in its previous stage vertices we need to select and calculate the cost. So substituting those values, again we get a certain values at every stages. Okay, and at every stages find out the vertex which produces the minimum cost and retain that particular vertex in the final solution. Okay, and at the end we will be getting the final answer. Again, that answer will be same as what we have derived in the forward cost or the forward approach. Okay, now try to trace this one in the backward path. The formula is given here and the values you can just keep on substituting the way we have done it in the forward technique.